Hello, you guys. Let's talk about Chapter 9, Lesson 2, Simplifying Square Roots. Now, simplifying is totally different from approximating. All right? Simplifying is very new, so please listen carefully. So, to know that we have something in simplest form, you have to keep going until there are no perfect squares left under a radical. You have to move them all out, and I'll explain that. And that you have no radical signs in the denominator of a fraction. Okay, and we're going to cover both in this movie. All right, so take a look at here. If I have the square root of a times b, I can break it apart to the square root of a times the square root of b. And I just showed you here, so the radical kind of morphs around both of them. And here, if I had numbers, the square root of 9 times 7, I can break it apart to the square root of 9 times the square root of 7. Well, you know the square root of 9 is just 3, and the square root of 7 you can't simplify anymore, so that would be in simplest form. Now, here's the deal, though. When I tried to show this, the first time I taught this, I showed it the way the book wanted me to show it, and my kids didn't really get it. My students didn't really get it. So let me show you another way here in the margin. If I have the square root of 63, what I want you to do is take that number under the square root, the 63, and I'm going to take it apart. I'm going to do a prime factor tree. So that would be the same as 9 times 7. Then I circle the 7 because 7's prime. And then I'm going to break apart the 9 to 3 times 3. And then I want you to rewrite it. So under the square root, I want you to write 3 to the second power times 7. Now here's the trick. You want to take as many numbers as you can outside of the square root sign. But they have to pay a price. They have to have a power of 2 in order to get out. All right? And then they can get out and be in front. So the 3 to the second power can come out. But when it comes out, the square root chops that power in half. So it becomes 3 to the invisible first power. So to get out, it has to lose its power. So it's 3 times the square root of 7. Okay? Okay, let's talk about example 1. So let's say I want to simplify the square root of 150. Write it over here, and then I want you to break apart 150, like we're going to do a prime factor tree. So that would be the same as 15 times 10, and then break apart 15, that would be 5 times 3, and break apart 10, that would be 5 times 2. Now, when you write it, I want you to write it in order. So put the square root sign, and then grab the 2 times the 3, but notice how there's a pair of 5s. So we're going to put 5 to the second power. Now remember, the only numbers that can get out of the radical have to have a power of 2. So grab the 5 and let them come outside the radical. But when they do come out, they have to pay a price. They lose that power of 2. It becomes a power of 1. So it's 5 on the outside, and then under the radical is still 2 times 3. Well, you can simplify that. 2 times 3 gives you 6. So the final answer here would be 5 times radical 6. Take a look at example 2. Okay, let's say I want to simplify the square root of 18t to the second power. Well, again, look at what I did here in the margin. I wrote the square root of 18t to the second power. So again, split these apart. So on one branch, put the 18. On the other branch, put t to the second power. And then break apart 18. That would be 9 times 2, and circle the 2 because it's prime. And then break apart 9 to be 3 times 3. Now you can also break apart t to the second power to be t times t. And then write everything under the radical, I did that over here, in order. So grab the 2 first, times, and then notice how there's a pair of 3's, put 3 to the second power, times, and then notice there's a pair of t's, so t to the second power. Remember, the people who come out have a power of 2. They're the only ones that can get out of the radical. So 3 to the second power can leave the radical, t to the second power can leave the radical. So then on the outside, I have 3 times t times the square root of 2. And then just simplify. Put it all together. That's 3t radical 2. So it's 3t radical 2, and that's our final answer. Okay, so let's practice this checkpoint. The directions say simplify. So here we have the square root of 75. So break apart the 75 to be 3 times 25. Circle the 3 because it's prime. And now let's break apart 25 to be 5 times 5. And then put everything back under the radical. So put the square root and then write them in order. Put the 3 first, and then there's a pair of 5, so put 5 to the second power. Now remember, the only numbers that come out of the radical must have that power of 2. They have to pay a price to get out. So that this comes out, and it'll be 5 to the invisible 1 power times the square root of 3, and you're done. Okay, take a look at number 2, the square root of 80. So let's break apart 80 to be 8 times 10. Break apart the 8, 2 times 4. Break apart the 4, 2 times 2. Break apart the 10, 2 times 5. Now, you look for pairs. We're going to put them in order. So I see a pair of 2s, so I put 2 to the second power times. Now I see another pair of 2, 2 to the second power times 5. Remember, anything to the second power gets out of the radical. It's like getting out of jail, but they have to pay the price. They're going to lose their power. So 2 to the second power comes out and becomes a 2. This 2 to the second power comes out and becomes a 2. And then the square root of 5, the 5 is stuck there. They can't get out. So then 2 times 2 makes 4. So it's 4 radical 5, and that's as far as you can go. Okay, take a look at number 3, the square root of 24r squared. So break apart, and on the first branch put 24. On the second branch put r to the second power. Now break apart 24. That's 6 times 4. Break apart 6. It's 2 times 3. Break apart 4. It's 2 times 2. Break apart r to the second power is r times r. And now remember, we have to write things in order, but you want to look for pairs. So I see a pair of 2s, so I put 2 to the second power. There's still one more 2, so I bring that down. There's 1, 3, I bring that down. And then there's a pair of r's, so I put r to the second power. Now remember, the only people that get out of the radical have to have the power of 2. So 2 to the second power can get out, but they pay the price, they lose the power. R to the second power gets out, and they pay the price, they lose the power. So there's a 2 on the outside and r on the outside, and stuck under the radical is 2 times 3. So now put those together, so it's 2r square root of 6, and that's as far as you can go. Okay, take a look at number 4, the square root of 56m to the second power. So on the first branch, put 56. On the second branch, put m to the second power. And now break apart the 56 to 7 times 8. Circle the 7, it's prime. Break apart 8, 4 times 2. Circle the 2, it's prime. Break apart 4, 2 times 2. Circle those 2's. And then you can break apart the m to the second power, m times m. Okay, now put things in order, but look for pairs. So I see a pair of 2's, so I'm going to put 2 to the second power. There's still one more 2, so I bring that down. There's a 7, I bring that down. And there's a pair of m's, so I put m to the second power. Okay, and I look for who's going to get out. All right, so 2 to the second power gets out of the radical, and m to the second power gets out of the radical. So I have 2 on the outside times m on the outside times, and then under the radical there's a 2 and the 7, and they're stuck there. They can't get out. And so it's 2m times the square root of 14. Okay, and then take a look at the quotient property of square roots. So if I have the square root, and under the square root I have a fraction, a over b, here's the cool part. The square root morphs around the top, the a, and the b. So it's the same as the square root of a over the square root of b. And if I use numbers, watch what happens. So the square root of 11 over 4 becomes the square root of 11 on top over the square root of 4. And then I just simplify. The square root of 11, I can't do anything, over, but the square root of 4 becomes the whole number 2. And then I'm done. Okay, so take a look at example 3. So I have the square root of the fraction 17 over 25. Well, let the square root go around the numerator and denominator. So that gives me the square root of 17 over the square root of 25. And then you just simplify. The square root of 17 you can't do anything with, over the square root of 25 is just 5. And you're done. Okay, take a look at number 5. So I have the square root of 5 ninths. And so it's the square root of 5 over the square root of 9. Well, the square root of 5 I can't simplify, but the square root of 9 is just 3. So it's radical 5 over 3. Take a look at 6. I have the square root of 21 over 64. So I put the square root of 21 on top over the square root of 64 on the bottom. Well, the square root of 21 I can't simplify, but the square root of 64 is just 8, so I put it over 8. Okay, take a look at number 7. I have the square root of 16z on top over the square root of 49. Well, remember, the 16 is a perfect square, so I'm going to say the square root of 16 times the square root of z over the square root of 49. I can simplify. The square root of 16 I replace with a 4. The square root of z I can't do anything with, I just copy it. And the square root of 49 is just 7, so I put that down on the bottom. Okay, take a look at number 8. I have the square root of 32y to the second power over the square root of 81. So 32, if I did a prime factor tree, would give me 5 2's. So I had a pair of 2's, 2 to the second power, times another pair of 2, 2 to the second power, times, there's still one more 2, times y to the second power. Well, remember, I want to bring this guy out, so that becomes a 2 on the outside. I'm going to bring this guy out. That becomes another 2 on the outside. And I'm even going to bring the y out. That becomes y. So it's 2 times y times the square root of 2. Remember, that lonely 2 is stuck there. Over the square root of 81 is just 9. And then I just multiply these. 2 times y gives me 4y radical 2 over 9. And there's nothing else I can do. Okay, so go ahead and lightly cross out example 4, but I would like you to write on this page your favorite perfect square root. Okay, so write your favorite perfect square root on this page.